All right, so the second part of our review here for the final, this is all on functions. That first one, take a look at it. You remember what the square root parent function looks like? Hopefully you remember. It's like goes through 1, 1, and over 2 up what? Over 4 up what? 2. Over 9 up what? 3. Okay, so it kind of looks like that. The next parent function we should talk about is that absolute value one. A V shape, yes. It makes the V shape like that and that. Okay, it also goes through 1, 1. Another one that you got to know. Parabola also goes through 1, 1. Over 2 up 1, 2, 3, 4. And so the common thing that they all seem to go through is 1, 1. So you can kind of look for that. And if you see a shape that doesn't go through that, you could feather it's been stretched. Exactly. Instead of this, it might go like this and through there. And see how that's the square root one, except it's been stretched up twice as tall. So looking at that 1, 1 spot is kind of crucial. Okay, other stuff that's really important. The stuff on the inside is stuff that's moving which way? Everything on the inside of parentheses is counterintuitive, you're right, but what about underneath like a square root thing? It's all left, right. And the stuff on the outside, like here and anything on the back end of it, the stuff on the outside is the up-down stuff, okay? So if I'm looking at this first one, it's on the inside, so it's all left-right stuff. What does that thing mean? Left-right flip, which goes over which axis? The y-axis, because you just think left-right, it's going this way, and it must be go over the y-axis. And then this thing is counterintuitive. It's not 1 to the left, which it seems like it should be. It's in fact 1 to the right. And this one is a what? That's what everybody says, and they're all wrong. Because it's not a multiply. It's not a multiply. That's a minus in there. So it's important to know the distinction between the two. If the 2 had been here, then it would be a stretch factor. But that's 2 minus this. So that's just like if this 2 is at the end. It's a positive 2. The negative is attached to the square root sign. So that is just like if I had gotten rid of it here and put plus 2 at the end. So it's on the outside, so it's up, down. So what is it? Up 2. All right. And this on the outside one, that's which kind of flip? Up, down, or left, right? Up, down, because it's on the outside, it's up, down. Up, down flips go over this, which means they go over the x-axis. All right. And this one today, I'm not going to be able to fool you again. Not a stretch factor. What is it? It's up 2. All right. Moving on. This is the same exact rules, just with an absolute value. So it's no reason to go over it all again. Inside stuff is left, right. Outside stuff's up, down. That's all there is to it. Okay. This one. Height of the water in my pool. So it's a day in the fall after I've had the pool all set up for a long time. It's getting cold enough, not using it much. So I start draining the pool. And I could ask you about this first section here. And I could say, in that first section, describe the rate at which the water is flowing out of the pool. And if you just said decreasing, you'd get it wrong. What are you supposed to say? Decreasing at an increasing rate, because it starts out going kind of slow, see? And then it ends up going pretty fast, see? So it's decreasing, but at an increasing rate. Now, why would that happen in the real world? Starts out and doesn't drain very fast, and all of a sudden starts draining much, much faster. Yes? Yes, if you blew a hole in the side of your pool, that would work. Somebody was talking about up one of those above ground pools, and I was saying, yeah, if you shot it with like a shotgun, like kept shooting it, it would go faster and faster and faster. Okay. Otherwise, if you're not crazy, maybe you just got like some leaves on your drain, okay, and your drain in your pool is not draining very fast. And so you tell your teenage son, to go jump in and get those leaves out of there, would you? And so he gets to the bottom of the pool and he like sweeps off the leaves, and then all of a sudden he's sucked to the bottom of the pool. Okay? Now that actually does happen, and people actually die doing that. Yeah, the whole little girl with the intestines thing. Yeah, I know, that was really, really gross. Yes, she did. She did for a while, but then she died of something else, so it was really sad. But the kid in the bottom of the pool thing, seriously, some of you guys have pools. I hope you know that. If you do go down there, they're supposed to have like safety things on them, but if your drain doesn't have one of those, you could get stuck to the bottom of the pool, and that's a bad place to be because you're underwater. Even if you're only like 3 feet underwater, if you're stuck to the bottom of the pool, you're underwater enough, and you can die. So while my son is stuck to the bottom of the pool, now water is going out, right? So what kind of rate would that be? That is a constant. It is not constantly increasing or decreasing. It's just constant. So the amount of water in the pool isn't changing. And then I finally get him pried off the bottom of the pool, and the water goes out again for a while until I get the stopper on there. Okay, and then we start putting water back in the pool after we've celebrated that he came back to life and all that good stuff. Okay, so that's a story that could go with the pool. You can make up your own. Parent equation for a circle. This is the base circle, and a parent circle would have a 0 and a 0 here because it isn't moved from the origin. Remember this? Okay, and what I taught you yesterday was about the whole ellipse thing. This is not on the final, but I want to remind you, brain research would say that if I don't remind you a few times here, you will forget this. When you have a number here and here, like 16 and 25, do you remember what those do on the ellipse? They stretch it. That 16, which kind of a stretch would it be? A left-right stretch or an up-down stretch? Left-right, and then what would the factor be? 4, okay, versus the other one would be a factor of what? 5, okay. Then, if I change this plus to a minus, it explodes my circle outwards, and it becomes a, do you remember the name? A hyperbola, you are correct. And actually it's an ellipse. The ellipse explodes and becomes a hyperbola, and I showed you how to do that yesterday. Anyway, not on the final though, but circle definitely is. Let's move on. If I gave you that, you'd be expected on the final to be able to write the equation for it. Would you please try right now to write the equation for that? Okay, so here's the base form for a circle, and then has this one been moved left or right, or up or down? No, it hasn't. So I could put zeros there if I wanted to. And then instead of 3, which would be a very common mistake to make, what should I put at the end? 9. Okay. And let's move on to another question like that. This one's got, oh, it's got some information already there. But it's pretty easy to see the center's 3, 3, and that the radius is 7, right? Please write me the equation for that one. And there it is. Nice job. Raise your hand if you had that one right. Good, then you guys get circles. This really isn't a circle question as much as it is a domain range question. Remember that? That's one of those things you have to know for all these things is domain and range. So what's the domain? Domains are the x's or the y's? Which are they? X's. The domain's the x's. So that's like from here to here. Okay, so what's my interval? From the smallest it can be to the biggest it can be. What's the smallest it can be when it comes to x? You have to count 1, 2, 3, 4, 5, 6, 7, 7. So from what to what? -7 to 1. Brackets, you are right. Okay, and then the range. The range is the smallest it can be to the biggest it can be. It's very easy to do that backwards. I did that in one of the other hours. From the smallest it can be to the biggest it can be. So from negative what to what? And then what brackets or parentheses? Brackets. What if you have to do a absolute value graph and you have to do a domain and range? What's the domain? Negative infinity, positive infinity, and brackets? No, parentheses. And from, on the y, it's a little trickier. 0 to positive infinity. All right. Okay. Almost done here. And I think that's enough for now. I'm going to pause.